this is Himabindu from the Department of CSIT. So today in this video I would like to explain about the context-free languages and context-free discriminate context-free languages and discriminate pushdown automata. So we already discussed about the pushdown automata and how to construct a pushdown automata, what is the definition, and we all discussed about all these topics in the previous videos. So here we will describe about the discriminate context-free languages and discriminate pushdown automata. What is this discrimination? So here we already discussed about the topic called discrimination. So in finite automata we have NFA and DFA. So DFA is nothing but discriminate finite automata and NFA is nothing but non-discriminate finite automata. So here like this, here also we have the discriminate pushdown automata and non-discriminate pushdown automata is there. So what is the difference between these two? We will discuss. So here if you observe this language, we already discussed about the non-discriminate pushdown automata. We constructed a pushdown automata for the language W reverse. So if the input value is about the 0 plus 1. So 0 plus 1 is nothing but the string which is starts with the 0 or 1 closure of 0, 1. So here the string which is going to be start with either 0 or 1. So here this language which says the W reverse. So here let me elaborate this language. So the string which is starts with a 0 or 1. So we can say that 0, 1 or 1, 0. So this is the string. We can say that. So suppose the string which starts with 0, 1 and the reverse, so this is the W, and what is the reverse of this string is nothing but 1, 0. This is W reverse. And one more string will take 1, 0, 0, 1. So W is the 1, 0 and 0, 1 is the W reverse. So and here 1, 1, 0. 0, 1, 1. So 1, 1, 0 is the W and 0, 1, 1 is the W reverse. So this is how we are going to elaborate this language. So the W, the word which starts with either 0 or 1, and here so W and W reverse. So in this case, so how to construct a pushdown automata? So here in pushdown automata, we already know that we have to move the symbols into a stack, and based on the top of the stack symbol, we are going to push or pop operation. Based on the languages, we have to perform this push and pop operations. Suppose here W and W reverse. So here this example is already explained in the previous videos, and now again we will directly taking this pushdown automata and we will see that how this going to be worked. And here if you observe W and W reverse, so here the string which is starting with a 0 or 1. So if this kind of two situations, so the string which is starting with 0 or 1, the string which starts with either 0 or 1. So initially the top of the stack symbol is Z0. So we already know that the definition of pushdown automata which is having the symbols Q is nothing but the finite set of states, and next input symbols sigma. So sigma which contains the 0, 1, and O for all output, O for the stack symbols. So suppose here we will write tau. Tau symbols are nothing but we are the pushing into the stack. Those are all named as a tau symbols. And initial stack symbol. So initially we are initializing the stack with a Z0, and initial state is a Q0, and final state is F, and transitions are delta. So here these are the definition. So 5 tuple, how many tuples? So here nearly 7 tuples. So 7 tuple representation of pushdown automata. So for this language we need all these tuples. So here in this one Q is a finite set of states. So this will be identified by the minimum length of the string, and next here Sigma is nothing but input symbol. So here input symbols which already given 0 or 1. And next tau symbols, we need to find that Z0 we have to include, and how many say our input symbols are there. Those are all pushed into that stack. So those are called as named as tau symbols. And Z0 is the initial stack symbol, and Q0 is the initial state, and final state and transition. So in the transition, we already know the transition of this pushdown automata. So first one is the state, Q0 we are taking, initial state we have to take, and this A is A is instead of A, we will write the input symbol. So W we can say that. So whatever the string we are taking, the W we have to take, and next top of the stack symbol. So initially we have to push a top of the stack. Initially we have to push one element into the stack. So initially we have the top of the stack symbol is Z0. So here, so W we have to push the string into the stack, and according with the top of the stack symbol is Z0. So this is about the transition. This already we discussed these three things. One is the state, and if W is the unconsumed input, and this is the top of the stack symbol. So which leads to the state, next state here, next state along with the W input symbol. What is the top of the stack symbol? So suppose W which is having 1 as an input, so 1 Z0 is the thing. So this is how the transition function of this pushdown automata. And if you observe this language which says that the 0 or 1, so in this one 0 or 1, we have to take the string which starts with a 0 or 1. So here for this case 0 or 1, we have 0. Suppose the string which starts with a 0 on top of the stack symbol is Z0, and we have to push that into a stack. So that is 0 Z0. And in case of 1, so in case of 1, we have the top of the stack symbol is Z0, and we have to push that into a push that into a stack. And suppose here 0 is there. So here we have divided this W and WR. The logic behind to construct this pushdown automata is, so whenever the word is having the input values, those input values are all pushed into the stack. So we have to push the word into the stack, and whenever we finish the W, and whenever we are starting this WR, whenever it is matching the symbols of input, we have to pop. We have to do the pop operation. So in between we have to do something. So what is that in the sense? So let me finish this one. So whenever the string starting either 0 or 1 and top of the stack symbol is Z0, we have to push those symbols into the stack. That is here happened. And here 0 and 0. So top of the stack symbol is 0, and next input symbol is 0. We have to push that into a stack. And here also whenever the top of the stack symbol. So here whatever there in the W, we have to simply push into the stack. That is the thing. And next here 1 is the input symbol, and top of the stack symbol is 0, and we have to push that 1 into the stack. And here 1 also. So here these are all the cases for the W, we have to push that into a stack. So whatever the symbol appears in the W, we have to simply push operation should be performed for the W. And next we have W reverse is there. So here in between one thing is there. Whenever the string empty and the Z0 is there, we have to do nothing. And here also 0 epsilon is there and 0 is there, and top of the stack symbol is 0, and we have to do nothing. And the epsilon symbol and 1 top of the stack symbol is 1, we have to do nothing. So here there is no operation performed, that is nothing but switching to pop mode. And next after this operation we need to switch to the pop mode. So how to switch that in the sense, whenever the input symbol is matching with the W string, so W string input, we have to pop that. Suppose here top of the stack symbol is 0, and whenever we are giving the input, consuming the 0 input, and top of the stack symbol is 0, we have to pop that 0. And here the same thing, 1 appears on the top of the stack symbol, and the consuming input is 1, we have to pop the stack. So here what is this operation? And finally, after consuming all the W and W reverse, we have the empty symbol, that is epsilon. So here after consuming all the input symbol, whenever it is reaching the epsilon symbol and top of the stack symbol is Z0, we have to move to the final state. So that is the Q2. So these transitions we already discussed. So here we are simplifying this WW reverse. Why it is a non-deterministic? So why it is a non-deterministic? So instead of this, why it is non-deterministic in the sense? So instead of guessing here, we need, if you add one more symbol to this one, it is very clear and we can say that it is a deterministic. So how we can say that? So here to remove guessing, so here we performed a guessing operation. So here instead of guessing, impose the user to insert C into the stack. So here instead of this guessing, we have to we have to give the symbol C in between W and W reverse. So here how we will construct for W and W, C, W reverse. And we can say that this is now WW reverse, the language WW reverse is a non-deterministic, that we can say that NDPDA. So non-deterministic. So WW reverse is a NDPDA. So non-deterministic pushdown automata. And if you give the input symbol C in between this W and W reverse, that is how language WCW reverse. So this is a non-deterministic pushdown automata. So how we will insert that symbol into the stack, we will see. And this is how. So here WC, W reverse. So C is some special symbol not in the W. So here W is having the zeros and ones, and there is a C what we are inserting, that is a not symbol which is not belongs to the string. So here the same thing, first step what we have to do, we have to W part is there, in between C is there and W reverse. So before this W, whatever there, the same logic, whatever there in the W, like 0, 1, 1, 0, whatever there. So we have to simply push that into a stack. So along with the Z0. So Z0 initially we have to initialize the stack, and whatever there in the input symbol of W, we will all push the symbols into the stack. And that is the thing. So whenever 0 appears on top of the stack symbol is Z0, we have to push the 0 into the stack, and these are all the operations. And next, after we inserted the C symbol. So C symbol appears, Z0 top of the stack symbol, and we have to do nothing. We have to skip that operation. So here no need to do anything. So whenever we see appears in the string, we have to skip or we have to switch to pop mode. We can say that whenever C appear, we need to pop the symbols in the stack. So that is the thing. And next, top of the stack symbol is 0, and we have to push the input symbol 0, and we have to, when input string is 0 on top of the stack symbol is 0, in pop mode we have to do. So same thing, we just implemented instead of epsilon, instead of guessing, we are inserting the C symbol. That is the same. That is the thing, we converted the non-deterministic pushdown automata to a deterministic pushdown automata. So how we can say that this is the this is the deterministic pushdown automata, in the sense there is a clear observe that C symbol, whenever the C symbol appears, we need to do the pop operation. So here there is a no guessing kind of thing, And the same thing here, whenever after consuming all the input symbols in the string, we have epsilon symbol. Whenever it is reaching the epsilon symbol and top of the stack symbol is 0, we need to move to the final state. So this is how we converted this the non-deterministic pushdown automata to a deterministic pushdown automata. Instead of guessing, we are just imposing a symbol C into the language, and these all the transitions have become a deterministic. Now the transition all are become a deterministic. And what is the definition of this pushdown deterministic pushdown automata? So as we already discussed, there is a no guessing here. So we have to combine the epsilon symbol also. So how to define this one? So a pushdown automata is deterministic if and only if this is the transition of Q is the current state and A is the input symbol which is to be consumed, and X is the top of the stack symbol. So has at most a non-member for any A belongs to. Here input symbol, what we are taking, the input symbol, the A is nothing but here suppose W10. So here the A is equal to 0 1 or 10, and here A is equal to 10. And here this is about the WW reverse, and here whenever the A deterministic, if it is a pushdown automata is deterministic, we also A also belongs to this A belongs to sigma. Sigma is nothing but either 0 comma 1. So here sigma is there. So belongs to sigma union, this union, and epsilon also. So epsilon also. So this is how. So here epsilon also, if you are including this epsilon symbol along with the input symbols, so those, that is also a deterministic. So that is a deterministic pushdown automata. And here this QAX, this is the transition of that. We can say that this is a discriminate instantaneous description. So instantaneous description is nothing but it is a 3-tuple notation. So is non-empty for some A belongs to epsilon, A belongs to sigma. Then transition of epsilon X must be empty. So here is the thing, and here non-empty set is, so for suppose this is a belongs to sigma, so here there is a no empty state. So here only strings values are there, and then this epsilon must be empty. So empty we have to consider here. So this is how we define the deterministic pushdown automata. So here simple thing what we have to do. So A belongs to what the input symbol, input string what we are taking, that is belongs to sigma I union empty symbol also. So this is about the deterministic pushdown automata definition. And deterministic CFL. So CFL is nothing but context free languages. So how we can say that this is a context free languages? So these context free languages and context free grammars, and how to define or how to construct, we already discussed in the previous videos. And how to convert this pushdown automata into a context free grammar and context free grammar to a pushdown automata, we already discussed. And what is this specifically deterministic context free languages? So what is this deterministic context free languages? In the sense, a language for which to construct deterministic pushdown automata. So here previously we discussed about the deterministic pushdown automata. So for that construction of pushdown automata, we used some language. So what is that language? In the sense, it is a deterministic context free language. Deterministic context free language. So the language, a language for which to construct a pushdown, deterministic pushdown automata. So whatever we are constructing for the deterministic pushdown automata, the language what we are using, those languages are named as deterministic context-free languages. Here we already discussed about WC, W reverse. Here, if you take one example and with this, how we can construct a pushdown automata, deterministic pushdown automata or not, we will see. So, WC, W reverse. So, suppose we'll take the string language which says that, so 0110, and here in between we have to include C here, and 1001 and 110, sorry, 110 1011 and so on. So this is the language what we are getting for the WCW reverse, and here we have to include C. And for the, if you take one string 10, the string W, sorry, the W here transition of, so here we already know that how many states are there. Q naught I am taking, and consumed input is 1, 0, C, 0, 1. And here, what is the top of the stack symbol is Z naught, and which leads to how whenever Z1 appears, so here the input string 1 we have to take, and top of the stack symbol is Z naught, and 1 is the input string. So the state it is having the Q naught. So here whenever 1 appears and top of the stack symbol is Z naught, what we have to do? We have to push that into a stack. Push that into a stack. So here what we have to do, in the same state, in the Q naught only we are having. So here 1 is there and top of the stack symbol is Z naught. We have to push that into a sim, and this is the thing. And next transition Q naught comma, we already pushed the 1 into a symbol, and 0 is there, and C 0 1, and top of the stack symbol is now 1, and top of the stack symbol, and we need to push 0 and top of the stack symbol is 1. What we have to do, we have to be there in that state only, and we have to push that into a stack 0 1. Why this 1 is in the sense we already pushed the 1 into a stack. And transition of Q naught, so where we are leaving a Q naught only, and initially C appears and 0 1, and top of the stack symbol is 0 now, and so here whenever C appears in the string and 0 whatever there, whether it is 0 or 1, what we have to do, we have to simply move to the Q1 state. So Q1 state, and with top of the stack symbol is again 0 1, and again here we have to take Q1 and C we already consumed, and top of the 0 we have to take, and top of the stack symbol is 0 only. And now whenever the matching appears, so here 0 is there and 0 is there, and in the Q1 state only we have to pop this 0. So here popping, after popping, what is the input value? 1. 1 is the top of the stack symbol and Z naught. And next, and Q naught, Q1, and we already consumed 0 and only 1 left, and what is this? Top of the stack symbol is now 1, and so here this is the top of the stack symbol. So 1 appears, we need to pop this once, and what is the next state? Only Q1 only, and we have to there in the Q naught. So Z naught is the top of the stack symbol after popping the operation 1. And finally, in this state transition of Q1 comma Z naught, so there is, if it is nothing there, so we already consumed all the things and we have only epsilon symbol, and top of the stack symbol is Z naught, we have to move to the Q2. So Qt is nothing but it is a final state and with the epsilon. So this is how we converted this. We discussed about the deterministic pushdown automata. So how we can say that it is a context-free language with the deterministism. We can say that with the language which construct a deterministic pushdown automata is called a deterministic context-free language. And here, if you observe the PDA versus PDA is nothing but pushdown automata, DPDA is nothing but deterministic pushdown automata, and regular languages. So here, what are the regular languages? So regular languages are nothing but finite automata. For the use of finite automata construction, we are using the regular languages. So this is also a type 3 language. So this already discussed what is the type of the languages having. We are in the Chomsky hierarchy, and how we can arrange the subsets here. So first we initially the type 3 language is there, and after that we constructed a pushdown automata, and for this construction of pushdown automata we need the context free languages. So that is the type 2 language. So type 2 language. So this context free languages are all type 2 languages, and here in this type 2 also we have deterministic and non-deterministic. So how we can say with the example we already discussed the language which is WCW reverse is the deterministic pushdown automata, and with the guessing and with the multiple option we can say that it is a non-deterministic pushdown automata. And what is the example of this non-deterministic pushdown automata? We discussed about W reverse, and so these are all the these are all the subsets. So here the type 3 language, so which is about the regular language, we already discussed in the finite automata. And here the pushdown automata with deterministic and non-deterministic we discussed it today. And these what are the examples how we will convert, how we will describe this pushdown deterministic pushdown automata we discussed. And these are all the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.